Right, the last section in 7.4 is arc length. A rectifiable curve is a curve with a finite arc length. So if you can measure it, it's called a rectifiable curve. If the derivative is continuous on a closed interval, then guess what? Continuous is a rectifiable curve. Okay, it doesn't even have to be a derivative. If any curve or any thing is continuous on a closed interval, then it's rectifiable. So a smooth curve, definition of smooth curve is not Kenny Randall. It's continuously differentiable. All right? So that's what it means. And to talk, why do I talk about this? Because arc length is a smooth curve. All right? And here is the formula. It's a very quick and easy formula. The arc length of f between a and b is this. It is the integral from a to b of the square root of 1 plus the derivative squared, dx. All right? And that is a smooth curve. And I'm going to prove it to you. I think this is one of the coolest little proofs I've ever done in calculus. Probably the only proof I've ever done in calculus. So going with that equation, the definition of the derivative is the slope here. So that's the slope function. Now what I'm going to do, my security blanket, okay, now what I'm going to do is get a common denominator. So I'm going to get this common denominator to be from x1 to x2. I'm going to get the common denominator to be x2 minus x1 squared, because that's squared over squared. So that means it will be x2 minus x1 quantity squared plus y2 minus y1 quantity squared all over x2 minus x1 quantity squared dx. So all I did was make one x squared, x2 minus x1 over x2 minus x1 squared. Both of them are squared. You can put the tops together, beautiful. Okay, so now what I'm going to do is I'm going to integrate this. Well, when you integrate this, I'm doing it with respect to x. I don't see any x's here. I see x1s, I see x2s. So when I integrate this, I'm going to get this whole thing. By the way, that's the whole thing. So the whole thing, which is this bad boy, squared plus y2 minus y1 quantity squared over x2 minus x1 quantity squared x evaluated at x2 and x1. So now what I'm going to do is I'm going to replace this and use the fundamental theorem of calculus. So it's going to be this x2, a lot of little writing here, x1 squared plus y2 minus y1 quantity squared all over the same thing. Oh, yes, yes. And then times x2 minus x1. Well, if I put this guy in the radical, you ready? Don't blink. If I put it in the radical, it becomes squared. And now these two will go out. And do you recognize this formula? You better recognize this formula. Okay, the math police will come and arrest you if you don't. But this is the distance formula between 2 points, because that's what the arc length is. The arc length between here and here is the distance between those two lines. And there it is, the distance formula. I think that's pretty neat. Whether you like it or not, you better say it's neat if you want a good grade. All right, now let's get to some problems that you might be indulging in. Okay, it says find the arc length from that interval. So what I'm going to do is I'm going to find the derivative. The derivative first is going to be x squared over 2 plus, minus, and I'm just taking the derivative separately here. So it's going to be minus 1 over 2x squared. So that's the derivative of that. All right. I'm going to put it all together, make it nice. So it's going to be 2x squared as a common denominator, and up top, this is going to be x to the 4th minus 1. All right, so that's just getting a common denominator and rolling. Now I'm going to throw it into my formula. My formula says it's from 1/2 to 2, and it's going to be 1 plus the derivative. So it's going to be x to the 4th minus 1 squared all over 2x squared. Okay, that's going to equal, and now I'm just going to roll it. I'm going to have to, I guess I can factor out the bottom. All right, I'll factor out the bottom. Okay, and this just becomes some tedious stuff, but whatever. You can handle it. It's all algebra. Okay, 4x to the 4th, and then this is going to be this squared, so it's going to be x to the 8th minus 2x to the 4th plus 1, and that's what I'm looking at right now. Okay, so far so good. Well, now what I'm going to do, so I'm just making it look nice. At this point, you could have put it in the calculator, got the answer, and been done. All right, but I'm going to show you how to do it by hand because that's probably where you're going to need to know. All right, because this is the part that'll make you a better math person, not just plugging it in the calculator. So I'm going to get a common denominator with this, so it's going to be 4x to the 4th plus 1, okay, and plus 8x, x to the 8th, I'm sorry, x to the 8th minus 2x to the 4th plus 1 all over 4x to the 4th. This is all underneath a square root. So what I can do is I have like terms here that I can get rid of. This is going to be now 1/2 2. This is going to be 4x to the 4th downstairs. On the top, that's going to be 2x to the 4th. Actually, I'm going to write it like this because you might see something, you might not. All right, what's up, man? And you're going to see x to the 8th, okay, plus 2x to the 4th plus 2, okay? That's actually why plus 2? Why plus 2? All right, because I'm not very good at mathematics. That one doesn't do it.
During the lunch period, and I'd like these students to come up to the main office. Again, we've had some issues during the lunch period, and I'd like these students to come up to the main office.
That's a 1. Because this is all underneath this. That goes away. That's why. There's only 1 1. All right?
Brendan Islinger, Riley O'Shea, and I believe it's Tom Thornton. Thank you. We look forward to seeing you up in the main office immediately. Don't pass go. Get up here.
All right, this factors to a perfect, I don't know, trinomial. A lot of things going on here. We have the announcement, blah, blah, blah. This is a perfect square trinomial. I got it out. It's x to the 4th plus 1, quantity squared. On the bottom is 4x to the 4th. All still under the square root. Oh, yes, but now we're getting rid of the square root. That's the goal. The square root's got to go. So now it's going to be just x to the 4th up top plus 1, and on the bottom it's going to be 2x squared. Whew. Getting there, folks, getting there. So if I break this up, this is all dx. I've been forgetting to write dx also. Wow. All right, now let's break this up. Crazy little problem. So we're going to have 1/2 to 2. Break this up, it's going to be, if I'm right, it's going to be, take the 1/2 out. So I'm going to take, you know what? I'm going to take that 1/2 right out. Get rid of it. 1/2 integral. So take this 1/2 out. This guy will go that way. And it's going to be 1/2. And we're going to get x to the squared. Because this is going to be this over x squared and that over x squared. Plus x to the negative 2 power dx. Now I'm going to finally integrate. Oh, yes. And get 1/2 x to the 3rd over 3 plus 1 over x. And I believe that's minus. Yes, yes. Okay, I'm going to evaluate that at 2 1/2. We're just about there. All right. So at 2, we're going to have 1/2 times 8/3 minus 1/2. All right. So that's going to be 4/3 minus 1/4. 12. This would be 16 minus 3. So we're looking at 16 minus 3, we're looking at 13/12, on that one. And we're going to subtract from that when I plug in 1/2. So I'm going to get 1/2, 1/8 over 3 minus 1 divided by 1/2 is 2. Okay? So now this becomes minus 1, this was 24, now it's 48. And this becomes plus 1. So I have this minus 1 over 48 plus 1. I'm going to common factor 48. So that's 48 over 48. That's negative 1 over 48. And I believe that's a 4. So this is 48. And I can multiply the top by 4. So I'll get 2, carry the 1, 52. So 52 minus 1 is 51. Hopefully this is good. And so we got 52 and 48 is 100 minus 1. We're going to get 99 over 48. If you wanted to simplify that, that's 33 over 16. Done. You're like, what just happened? You know what just happened? About 3rd to 5th grade just happened. Arithmetic. All right? Maybe 6th grade with the fractions, okay? Yeah, you got to be able to do this. Obviously, using a calculator is easier, but that's how you do it. Once again, just to reiterate myself, it's going to be that formula, 1 plus the derivative. Okay? 1 plus the derivative. Actually, it's the derivative squared. My bad. And this formula right here, derivative squared. And then I just worked it out from there. I did algebra and got it down to an answer. What I want you to do and try is 5, 7, and 9. I want you to try raw, like I did it, with the calculator. I mean, without the calculator. And then, actually, we'll do these in class with the calculator. We'll do 18, 24 even in class with the calculator. So just do those 3 problems without the calculator for homework. And I'll just show you this because after that, you need something to make you feel good. So here's my impression, Russ, of SpongeBob. A much better SpongeBob than you have ever made. Okay? I challenge you to a SpongeBob drawing contest. No, I'm just kidding. Here's SpongeBob. Have fun with it. I'll see you.